All right, we're looking at section 3.1, graphing points. So this is the first section of chapter 3, which is all about graphing. And so we'll be graphing points. Why do we use graphs? Well, one of the reasons we use graphs is to make information easier to understand. Each of us has a kind of a specialized thing that we're good at, whether that's working with art, whether it's working with science, math, maybe we work with certain kinds of maybe we work with cars, or maybe we're really good at cooking or something. And each of those things has a specialized vocabulary. And if we use our specialized vocabulary, well, it's kind of hard to understand stuff. So for example, if someone works in medicine, they may have specialized vocabulary, for lungs, pulmonary. Well, pulmonary is not a common word. Most of us know the word lungs. So we need a way, when we're talking about math or science, to be able to make information easier to understand. And so we use graphs. Let's see some examples. The first example is healthcare costs in 1960 to 2020. This graph basically says in 1960 that the annual healthcare costs was $27 billion. If we fast forward to 2020, it says it's somewhere around 4,487 billion, which is $4.5 trillion. So somewhere around $5 trillion. So if I was to present this in a chart, in a table, this might be hard to understand. If I was to say f of x is equal to 5e to the 2x, that would be not necessarily something people understood. However, if I just give you this bar graph, you can see that it's increasing really fast. It goes from 27 to 75, to 75 to 256, and 256 to 724. You can see that it's increased, that the cost of healthcare is increasing very quickly, which is essentially what an exponential function does. I mean, but this chart makes it easier. I don't have to understand exponential functions. All I have to do is be able to read a chart. So that's one thing. All right. This chart talks about the concept of flattening the curve. So right now, with all the stuff we're dealing with, we're talking about what happens with protective measures, what happens without protective measures. So this is our healthcare system capacity. This is the time since the first case. We basically want to make sure that we don't overwhelm the healthcare system with lots and lots of cases. If we do it without protective measures, what basically happens is you get a whole bunch of cases in a short amount of time, which basically brings our healthcare system to its breaking point. If, however, the spread of the disease is slower over time, so you see slower over time, a longer period of time rather than a quick period of time, then we can see that we are within the healthcare system capacity to deal with it. So basically, the idea is the slower the spread of the disease, the more time healthcare workers have to deal with the problem. That's essentially the idea. That's essentially the idea of flattening the curve. This is a graph of the real GDP in the United Kingdom. Now, you don't necessarily have to understand what a real GDP is for the UK. All you really have to understand is, I can clearly see from this graph that it's increasing. How do I know that? I can just look at it. I don't have to understand anything about the UK, and I don't have to understand anything about the GDP. All I have to do is look at it, and I can know all the information I need to know. just from looking at the graph. So that's what graphs do for us, is it takes something that can be really complicated and it actually simplifies it down to something that is not complicated. Without me having worked very hard, I can see it has mostly increased over the years. And it's increased pretty gradually as well. Not very quickly, pretty gradually. Those are both things that I can see from looking at the graph. What we're going to be doing is going down to the simplest level. We're going to take linear equations, aka lines, and turn them into graphs, which are pictorial representations of lines. They're pictures of lines. So for example, if we take this one, we have y equals 3x plus 1, it looks like this. And we're gonna be able to draw that eventually. All right, to begin with, we're gonna start with some basic graphing terms. We're gonna start with the XY graph. The XY graph is also known as the coordinate plane, but it's also known as the Cartesian plane. And there are 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice it goes counterclockwise, not clockwise. So it goes counterclockwise. So if you're thinking about the way a clock works, it goes backwards to that. All right, there's also a point in the center called the origin. And you can see I have these ordered pairs lined up here, and we'll talk about that real quick. All right, another important term in graphing is called the ordered pair. It's also known as a point. An ordered pair is composed of 2 parts, an X and a Y. The X is the first part, the Y is the second part. Just think about it alphabetically. W, X, Y, Z. It goes in order, it's a pair. It's X, Y, not Y, X. It's always X, Y. It goes in order. The X tells you that something goes left or right. The Y tells you that something goes up or down. So let's look at that. How do we graph an ordered pair? So how do we draw a picture of an ordered pair? Well, think of it like a north, south, east, and west kind of thing, right? We know north, south, east, and west. The X value basically runs east and west, or basically runs east and west. The Y basically runs north and south. So the X is going to move left or right depending on the X value. This is the positive X direction. This is the negative X direction. This is the positive Y direction. This is the negative Y direction. The only thing that's tricky is sort of remembering negative X, positive X. But once you label your graphs a whole bunch, you'll kind of see that. All right. Steps of plotting a point are you start at the center of the graph, called the origin, this dot right here in the center, and you move left or right depending on the X value. In this case, the X value is -5, which means it goes this way. -5 units. And then we have +3. +3 is a Y value, that's up or down value. It goes like that. So it goes -5, +3, and we put a dot there. So again, X goes left to right, Y goes up or down. All right, there are 4 quadrants. The 4 quadrants are Q1, Q2, Q3, and Q4. The first quadrant, the second quadrant, third quadrant, and the fourth quadrant. They're also can be referred to by Roman numerals, so you may see the Roman numerals for them. I, I, and IV basically refer to 1, 2, 3, and 4. I have it listed out like that. All right. In the first quadrant, the ordered pair is positive, positive. So X and Y are both positive. In quadrant 2, it's negative, positive. So X is negative, Y is positive. Quadrant 3, it's minus, minus. So X and Y are both negative. And quadrant 4, you got positive, you got plus, minus. So X is positive, Y is negative. So how we use that? So where is the point 2, 4 located? Well, let's look at our little chart here. It's a positive, positive. It's got to be in the first quadrant. because everything in the first quadrant is a plus plus, a positive positive. All right. Then we have negative positive. So only we're looking right now is signs. We have a -7 and a +8. So negative positive has to be in the second quadrant, quadrant number 2. And then you've got -8, -4. -8, -4 is a negative negative. Got to be in quadrant 3. That's what happens in quadrant 3. You have negative negative. All right. Now the question is, what are points on the line? If the points are on the line, it look like this: -5, 0, 4, 0, and 7, 0. Now, what do they have in common? Well, what I noticed is that the x's, the first numbers, are different, but the second numbers are all the same. I have a 0, 0, 0. These are all points that are on the x-axis, and they all have the same second number. Now, if we go back to the slide we did before, what did it tell us? It said that y is the second coordinate. So in this case, the second coordinate, i.e. y, is always 0. Now, if we look at points on the y-axis, we notice that the first number is always 0. That is the x-coordinate. Because remember, every ordered pair has an x and a y, and x is always first, y is always second. So we summarize it like this. Every point on the x-axis has a y value of 0. That's true for every point that is on the x-axis. Every point on the y-axis has an x value of 0. That's true for every point that's on the y-axis. So that means I can know automatically where things are located simply by the fact that I have some information. Where is the point 90 located? Well, I look at it and I go, well, the y value is 0. Well, no, what that tells me? It tells me that we're on the x-axis. If I look at the point 0, 0, the x value is 0, I know it's located on the y-axis. So that's just things I know just by looking at it. All right, that is a basic summary of graphing points, locating them. The homework for it should still be open, so just make sure that you get that done. And I'm finished.